I finished the lessons for this class, I'm gonna make a playlist for A-level chemistry. So you're on the playlist for my YouTube channel. All right, so we're gonna go ahead and get started at this time. First, we're gonna go ahead and review that bell work. And I was looking over this lesson, and I didn't want to change anything dramatically because the next lesson as well, Unit 5, Part 4, is not that long. Unit 5, Part 5, though, is very long because that's going to be analytical methods, meaning, remember how we did IR with the graphs to determine functional groups? And we learned mass spec to determine molar masses and like fragments of molecules last year. Remember all those graphing things? Well, there's more. So we have to go back over that, and we have to go over more types of graphing methods. Those types of graphing methods to determine what molecules are based on, like, you run the sample through the machine and it tells you what you have. That's what actual practicing chemists do. And so if you want to find out what you have, or you're trying to synthesize a specific product and you want to be sure I made a pure product, you utilize those methods. So that's going to be pretty much the second half of this unit is separation methods and then analytical methods. And so there's a few reactions. It's basically mostly just this condensation and polymerization stuff. But then most of this unit is actually on analytical methods, which we're starting to look over today. And then we're going to go deeper into next week. So expect to look at graphs a lot starting next week. I believe there's 6 lesson days. So this will be the end of the first half of the unit. And you can expect the test for this to be somewhere towards the end of the month. I'm waiting on one thing that I find out tomorrow. There's a conference that I have to attend twice a year. I've tried to get out of it, and I'm not allowed. So I'll be attending that conference. I just don't know if it's an A day or a B day yet. So I'm supposed to find out tomorrow. And so next week I'll have, a better schedule of what exactly is happening for the rest of this month. There's one day that I don't know if I'm missing or not. I also know that we have college tour towards the later part of this month, and that will be actually is that the 20th? Is the 26th and 27th?
Wait a second.
So it's that same weekend
I just realized.
of the math thing?
My God.
Oh, okay. Well, that makes things even trickier.
Jesus.
Because that does affect the schedule a lot.
Wow.
And that's most 11th graders will be out on college tour. So just FYI.
That's college tour right before.
So
What?
planning and scheduling gets a little bit grainy at this time. So once we get a little bit closer to the time, I'll lock down whenever our exam date is, but it's not yet. It's at least 2 weeks out. And once we get to the graphing part, the part where you need to like read the graph to interpret molecules, that might take even more than just the lesson days. You might need to just like review that thing because it's a little complicated, but it's very interesting. And if you are going to study something like forensics, I know that some people are interested in forensics. That is something that it's right down your alley because it's something you would do to identify like a drug in somebody's system. So with that being said, let's go ahead and get started with reviewing today's bell work. The question that was missed most, I think, was this first one. And I think it's a problem with just remembering, first of all, something from AS Chemistry. Second, reading the question. It says, draw diagrams. And I don't believe I mentioned it, but whenever it says draw, does that mean pen or pencil? That word diagram tells us pencil. So that means if you mess up, you can fix it. Draw a diagram to show how the carboxylic acid and amino groups of alanine, and they show you part of it here, can form hydrogen bonds with water molecules. And so all you needed to do was, and I know some of you drew out alanine and you did it that way, and I'm pretty sure they would accept that. But all you needed to do was show for the carboxylic acid, water being attracted, the oxygen of water being attracted to the hydrogen of the carboxylic acid. And then for the amino group, like this.
Have you done the hydrogen for the oxygen?
Yeah. Yeah, either way. However you faced it was fine. And so that was the first point, was just to show hydrogen bonding. The second point is the Zwitter ionic form of glycine. Now notice how they gave you the R groups here. For today's lesson, I noticed as I was solving the questions last night, you may want to have out your workbooks. In the back of your workbooks, there is a data booklet. And in that data booklet, I put the amino acids there because you don't have to memorize them. So you will want to have your workbook turned to the page in the back that has the amino acids for today's lesson. But for here, they gave it, so we just use what we're given. So glycine, that's hydrogen. So I know I've got C. I know I've got glitter ion, so that means what about my carboxylic group? It should be charged or not charged? Charged. CO minus. This is H3N with a plus. And then hydrogen's always there. And then you put your R group. Your R group this time is hydrogen. So this is how I would have drawn it. But if you did skeletal, structural, displayed, as long as it's got all the key components, it's fine. And that was a mark, 1 mark. The next question. And we definitely need to practice with this more. There's something that I guess was a little unclear in the last lesson. And it might have been because we didn't do anything with the alcohol group, but you do have to do something with amine groups and carboxylic groups. So when we have a pH of 1, what does that mean? Very acidic, right? Lots of H plus in the solution, which means you have to give H plus to every group that can take it. And by group, I mean functional group. And you need to do yourself a favor and memorize the acidic functional groups and the basic functional groups, because those are the ones that change form. And I went over that in the lesson. The acidic functional groups, just as a reminder, I'm going to write it again. Acidic functional groups are carboxylic acids, right? COOH. And there is another one you have to be aware of. What's the other one? Even though we haven't really officially introduced it yet, you still have to know it. It's phenol, which is benzene with the OH. Those two you have to know are acidic. And then for basic functional groups, I believe there's only one that you need to know. And what is it? Amine. Not amide. Amine. Right? And then neutral is actually amide. And what I had mentioned last class is that alcohols, although slightly basic, and we will cover that again, it was covered in AS chemistry, they actually are not basic enough to be included in this. So this is all you got to remember for what are your acidic functional groups and what are your basic functional groups that will either gain or lose hydrogens. And so for lysine, lysine has amine. So that means at a pH of 1, what does that mean? The carboxylic would get its hydrogen. The amine group, here we get its hydrogen. That's just a hydrogen. And then for lysine, which is 4 carbons and an amine at the end, right? Attached at the carbon, not at the amine. I think a couple people accidentally made mistakes with that. The carbon gets attached, not the amine. This would be NH what? NH3 plus. Because this is a basic group that's turned acidic because it's in low pH. So that means that all bases have to receive H plus at a low pH. And so I think a couple people got confused. They thought the R group never gets touched. That's not true. The R group does get touched if it's an acid or a base. The other example that we did was specifically with an alcohol. That's why it got confusing. But if it's an acidic group, you have to give the hydrogen. If it's a basic group, you also have to give the hydrogen. And if it's in a basic solution, what do you have to do instead? This is take H plus away from every acidic group. So you would leave your basic groups alone. They would exist in their base form. And the acidic groups, you would take the H plus away. So that means all carboxylic acids would exist as COO minus, and all phenols would exist as O minus. And so how would this end up looking for aspartic acid? Aspartic acid is right here. CH2CO2H. It was given to you in the thing. So it's CO2 minus, H2N, H. And then down here is, I think, CH2CO2 minus, like that. Check your answer to see if that's what you got or if you made any mistakes. And it's 1 mark for each correct box here. The last question, the drug remifentanil, I don't know if that's actually useful for. The drug remifentanil is shown. So remifentanil is completely hydrolyzed under acidic conditions. I think you could look up what it is used for, because if questioned, you can go back to this presentation. What is it for? It's an opiate. Oh, so it is kind of like fentanyl, right? Why do they make you think? Whatever. Okay, so they presented you with a drug, and they are saying that it's completely hydrolyzed under acidic conditions. Acid is important because you have to know whether you're under acidic conditions or basic conditions. If it was hydrolyzed with H plus or with NaOH, you get different products, you remember. So this is acidic conditions. And they tell you that there's 3 different organic molecules that form. There's actually, I think, 4 products here, but the thing is 2 of them are the same as each other. So that's why they're just asking you to draw the 3 unique products. And so draw the structures for these compounds in the boxes. I drew it skeletally because I'll always draw it the way it's presented. That's usually how the mark schemes are. But if you wanted to go displayed, I saw at least one person that displayed every single hydrogen. Just make sure that you don't make a mistake and you don't miss a hydrogen somewhere, because they will be brutal if you give it the wrong amount of hydrogens. So I usually just stay safe and go skeletal to not mess up on that. So where are my splits? There. Right here. Where else? There's one more spot.
Amazing.
The amine. Or it's the amide, right? It's an amide. And so that gives us our 3 unique products. These 2 are actually the same as each other. That's why there's only 3 boxes. And this one right here is BOH. Now I saw at least one person made a mistake where they wrote that as an answer. That is not acceptable. Why not? The one at the bottom. Why is that not acceptable? Francesca.
It doesn't show people on something. It doesn't press separate radical.
Because it would technically be what you would be presenting is this. What you're presenting is that if you don't write the hydrogen. You're saying it's free radical oxygen at the end. And the problem is that when you draw skeletal, you're not actually showing the full list structures. So that's where those little tiny mistakes get made. But Cambridge would definitely read that as wrong. And so the idea is that you have to show the hydrogen if it's connected to an oxygen or a nitrogen. You don't have to show the hydrogen and skeletal if it's connected to a carbon. So that's where the confusion can be. So this was the right way. And then for down here, I do the next piece, this one. That's a carboxylic group, right? So this would be that. 3 carbons. And I just kind of like copy paste and add in the groups. And then the hardest part to draw is this. That's 1 mark to draw all of that correctly. So it's 1 mark for this correct, 1 mark for this correct, and 1 mark, and this is where they give the big box, for all of this correct. And so the part that I circled would be, again, I'm copy pasting, and then just adding the ends in. This would be carboxylic. I think this is why I spend so much time, like, there's just slides in the lesson because the molecules are so large. It's just an amount of drawing you have to do. And remember, if you miss one carbon, it's over. Like, you don't get that one mark. That's why I always found organics kind of brutal. And then here. And what else? I'm still missing one thing. What am I missing? The H that goes for the nitrogen that completes it for its octet. You have to draw that. Yes. I'm sorry? Oh, it's not recording?
Is it? I don't know.
It's recording. Thank you. Okay, so that's the, I decided to record also covering the bell work just because I wanted to go back and reiterate a couple of things, specifically with the acidic and basic functional groups, just to make sure that you got the idea of what you needed to do. So these questions are a little bit overwhelming at first, but once you get the key idea of what you're taking away and adding, hopefully it's not too crazy. We have one objective today.
So.
That's for a reason.
One objective, that's a good sign, right? One
So you definitely needed to understand last lesson to be able to interpret today's lesson. So this is the last objective with amino acids. And that objective is candidates should be able to interpret and predict the results of electrophoresis on mixtures of amino acids and dipeptides at various pHs. So we're going to go over a couple things we went over last class, and then we'll get straight into what we're doing here. The lesson actually won't be too long. It just depends on how long it takes you to understand the idea. Okay, so first off, review. Isoelectric point, something that shows up in the homework too 3 times, that definition. So this is the definition I picked up from the textbook. The pH value at which there is no overall charge on a particular amino acid. You can also say, because I've seen it in many mark schemes, the pH where this Witter ion exists, or the Witter ion exists. So that's what we call the isoelectric point. And so here, this graph right here tells you, look, you see pKa? That's fun. Do you remember what that is? What's pKa? What is this graph trying to tell us?
Negative log.
It's negative log of the Ka, right? Yeah, pKa is negative log of Ka. What's the Ka? Keep moving forward. What's the Ka?
The equilibrium constant of the dissociation of a which has
Ka is equilibrium constant for dissociation. That's pitch perfect response. Dissociation of a weak acid. Okay. So what is this graph then trying to tell us? It says there's a pKa, another pKa, and another pKa. What is that? Take a look at aspartic acid on the side. So there's a pH less than 2. You've got this form with all of these H pluses, right? You've got pH of 2.8 and you've lost 1 hydrogen. You've got a pH of 7 and you've lost 2 hydrogens. You've got a pH of over 10 and you've lost all 3 hydrogens. So what are these telling you? What are the pKa's telling you?
I think that's
concentration.
So at pKa1, you're losing the first hydrogen, the most acidic hydrogen. At the second one that's here, you're losing the second most acidic hydrogen. And at the pKa at the highest number, you're losing the least acidic hydrogen. And when you have acid, I don't know if you recall, the first H plus is the easiest to leave. I might have brought this up in AS chemistry. I cannot remember for sure because that class is at a breakneck pace. But I do want to bring it up for sulfuric acid. And you can look this up for other acids as well. For sulfuric acid, the first hydrogen is actually the only one that's strong. As I said, I don't know if I remember going over that in AS or not. I might have. And then the second hydrogen and sulfuric acid has an equilibrium, meaning it has a Ka, meaning it has a pKa. Yes, Ramon.
Yeah, I do think you went over this in organic.
Probably
Yeah.
towards the end of the year last year. But the idea is that the concept is that the first H plus that leaves is the strongest. That means it'll have the lowest pKa, because the lower the pKa, the stronger the stronger the acid. There's something else here. This PI. I believe this is meant to tell us the isoelectric point. For whatever that specific acid is. The isoelectric point, look it up, but PI, I believe, means isoelectric point. And so this right here actually is a very important spot on a curve. And for those of you studying for the Olympiad, you might want to know this. In a buffer solution, which weak acids and their conjugate bases are buffered solutions. This would actually be where when you have pH equals pKa plus log of salt over acid. I know you're so excited to see that equation again. Does anybody remember what that equation is? Called the Henderson-Hasselbalch. But this is the exact point at this halfway point right here, where the salt and the acid are the same as each other. And so the pH would always equal the pKa. So actually the value of the pKa is the pH when your salt and your acid amounts are the same as each other. On the Olympiad, so this would not show up on a Cambridge exam, but if you are studying for the chemistry Olympiad, there is definitely a plausibility that you would be given a graph like this and have to understand this concept. So you might want to have that down, especially if you're going to be studying for the Olympiad, which is in a month, a little bit less than a month today. But I did want to bring up, like, this is what the graph communicates, is that this is the first H plus getting dissociated, and then there's a second H plus getting dissociated, and then there's a third H plus getting dissociated, because there's 3 different H pluses that are on aspartic acid at a low pH. And so, practice questions. So it says to find your structures of amino acids in your data booklet, just in case you don't have that with you, I'll go ahead and tell you the R group, because I do have it, for valine and lysine. So valine, the R group is CH, CH3, CH3. So before we get started, try this question. You're going to do something with it in a little bit. It says valine and lysine are amino acids. The structures of these can be found in the data booklet. The isoelectric point of an amino acid is the pH at which it exists as its with their ion. The isoelectric point of valine is 6. Draw the structure of valine at 6. So how would we draw it? What are the 3 groups I have to have? I have to have, for an amino acid, 3 specific things always. What's the first one? Atzel.
Carboxylic acid.
I need carboxylic acid. Now, should it be written COOH or COO minus in this instance?
Minus, right?
Yes. Because we're at the isoelectric point. So we're at the Zwitter ion, right? What's another group that has to be there on the amino acid? Which one? H. The H. Yes. What's another group that has to be there on the amino acid? The amine part, right? One of the amino acid. So H3N plus. And then this right there just goes to the bottom. Is that acidic or basic? Neither. And we're at the isoelectric point anyway, so you wouldn't mess with it regardless. Because remember, at the isoelectric point, you have your Zwitter ion, you don't have an overall charge on your molecule. And so that's that. How many marks is this? Single marks. So with this information, we can start talking about our first actual separation method. This separation method is actually used way more in biology/biochemistry. In this course, the A-level chemistry course, they talk about electrophoresis for only amino acids, but electrophoresis is actually more commonly used for DNA separation. And so it actually gives you like the DNA, like it's how you can tell, like, you know, if you have matching DNA or not. You can use something called electrophoresis. But the concept is similar. The prefix here, electro means what? Electricity. So you're actually taking a gel and you're putting electricity through it. And it's a buffered solution. So it's used in biochemical analysis. And we use it in this case, we're only talking about proteins, but like I said, you can use this for DNA as well. You use this to separate proteins, identify proteins, and purify proteins. Proteins can be separated, identified, and purified. And so this is what we use to identify different amino acids. And so it's called electrophoresis. I had considered when I was doing the order for the donors choose, I didn't end up getting it, but it was one of the devices I was considering getting, but I didn't. I have to see if the school has one somewhere. I had thought that Purcell said that there was one, but to look around Aswarte's room and see if there's a electrophoresis device somewhere in there.
I have to like search the whole school, like
Search the school. I mean, there's still stuff. I've been here working here for this is my 6th year here, and I still find things like in the back stock room that I didn't know existed. Like the 3D printer that we used for STEM Challenge last year. I went 3 years not knowing that even existed. So, you know, could be somewhere. But the idea of it is that you have a power supply and you're putting electricity through it. So you've got a positive electrode and a negative electrode, an anode and a cathode. And so your positive electrode and your negative electrode, the way that it works is you put your sample of whatever you're trying to analyze into the machine. And if you have positive ions, they'll stay close to the negative end. And if you have negative ions, they'll move towards the positive end. So based on the charge of the amino acid that you have will be how it moves. So it's based actually on 2 things, the charge of the amino acid and the size of the amino acid. And so positive ions would be attracted to that negative electrode, and negative overall ions would be attracted to the positive electrode. And then the other thing to be aware of is the smaller your ion is, the farther it's going to move. So larger means slower. It's not going to move as much. It's not going to be able to move as much. And so on the next slide, there is an example of a DNA electrophoresis. So this is a DNA electrophoresis, just so you can see what one looks like IRL, like in real life. This is how one could be presented. And so when separating a mixture, you get something like this from a DNA electrophoresis. And this is kind of how you can match DNA. So for example, if there's a crime scene and you find a sample of DNA and you need to match like who could possibly be the murderer, you can find a DNA on the scene, match it to their DNA, and see if it gives like the same lines. And if it gives lines at the same places, you're like, got you. And if it gives like a different set of lines, it's like, nope, not that person. So that's kind of how DNA analysis works, which I think is really cool. And I'm sad they took that part out of this class, but I wanted to at least show it to you so you could see like how that looks like. So if you study biochemistry or forensics, you would actually work with this type of equipment. So how does it work for proteins? So if you have a positively charged ion, so not a Zwitter ion. Zwitter ion is actually neutral. I don't know why I left that there. So the positively charged ion is going to move towards the negative plate. And wherever you put your proteins at, they're all going to migrate through that gel. And so you have a gel between 2 glass plates, kind of like what you do with little microscope slides. You put a little gel in there, but it's bigger than the microscope slides. But you put a little gel in there, and then you put your sample in a well plate, and it moves up. And the idea is that the smaller it is, and here the more negatively charged it is, the more it would move towards the positive end. So let's take a look at how we would look at that in application. And by the way, I have looked for like YouTube videos on this topic, and there is very little out there for this specific topic. I was looking last night and I looked here and I still haven't found one that I liked. So we just have to go with what we have here from the textbook. A mixture of 3 amino acids is separated by gel electrophoresis. The 3 amino acids are glycine, valine, and phenylalanine. And it says to draw them in the space below. So we're going to start by drawing them. I'm going to go ahead and draw them for you, so just go ahead and track along, just in case you don't have your data booklet with you. Glycine. So just the regular one. Valine. And phenylalanine. Do you have to remember these structures by heart? Like all of them? Do you have to remember all your R groups? No. In the newer tests, they're going to be provided for you in the question somewhere. Kind of how it was in the Bo work where they give you the R group on the side so you know which one you have to pick from. So this is glycine, valine,
I do remember.
I forgot.
and phenylalanine. Phenol with a YL always means benzene, by the way. Benzene coming out of the chain. So phenylalanine. All right, I'm going to pause to give you time to draw that. So that's presented information. And then we're going to take a look at the next slides to see how we would answer the type of questions we could be asked here on protein separation.
Oh, we're not throwing the mixture?
We will. So draw them in the space below. And then I made sure I printed out in such a way where on the bottom, you can actually draw the ions present at a specific pH. So you could just look up to see how to do that because they're on the same page.
Big brain.
Yeah, big brain. That's what I get from all the questions in advance. Is then I could have added, I'll be like, switch my bell work slides, add one more, take one away. So it works out nicely. All right. Are we good? We got this written? No? Okay, I'll pause. Like I said, it's actually not a long lesson, but just the amount of drawing is the problem. So much drawing.
Oh, it's the fun of it.
Just don't miss a carbon. A bunch of hexagons, yes. Continue? No? Yes? We're good? Okay. So, buffer solution pH of 10. You do need to make an assumption that this is basic and a high pH. If they did not give you the isoelectric point, you can go ahead and assume if it's in a basic media that we are at high pH conditions. So this means that we are taking the OH minuses and we are using those OH minuses in the high pH solution to take the H pluses away from anywhere we can. So rewrite glycine in alkaline conditions. And that's the key word. They told you it's alkaline high base conditions. So how would we rewrite glycine? Glycine is that first one. How would we rewrite this in a pH of 10? Adds up?
It's fine. Let her go.
Okay, Isa?
COO instead of COI.
And does anything else change? So everything else remains the same from the normal one. That's glycine at a pH of 10. What about valine? Wouldn't it just be the same thing, just a different R group? Because all these R groups are not basic or acidic. So valine, you would do the same thing. COO minus. And then phenylalanine, you do the same. And the reason you're being asked to do this is because of the next question coming up. So I'm going to give you time to write that out. It's literally just the same things, but you took the H plus away from the acidic group because you're in a basic pH, which is why I said from last lesson you kind of had to get that down for what we're about to do now. On the next slide, that's where the new standard is. It says, I'm waiting, draw a sketch of the electrophoregram you would expect, labeling the amino acids as gly, val, and phe. So I'm going to show you how to do that. So from the textbook first, and then we'll take a look at it as a Cambridge question. Okay. Pausing to make sure that you've gotten this. Give about 20 more seconds. It's a lot of drawing, like I said. All right, so how would we draw an electrophoregram? And thankfully for the Cambridge questions, they usually give you like a sketch of it, and then you just have to fill it in. You'll see if you go a couple slides ahead that they typically just give you this and then ask you to interpret it. But how would we come up with it ourselves is the idea. Draw a sketch of the electrophoregram. So that's how the samples move in the gel plate that you would expect. Labeling the amino acids as gly, val, and phe, and then explaining on the side. So first thing, draw a little rectangle. And then put a positive end and a negative end. And then this right here is where you would add in your samples. So we call these well plates. Samples added here. So the question is, which one travels the farthest? How would we figure that out? Out of these three, which one travels the farthest? What are the two factors we should look at? Two factors to consider. Ben Kobe, you want to try?
Yeah. I was gonna say polarization, maybe.
Can you say that in a different way?
Uh,
So what are the two factors to consider before we answer the question? What affects how far they move? Issa, go ahead.
The charge and the weight.
So the charge of the amino acid and something in Cambridge we call the MR, the molecular mass, the relative molecular mass. You'll see MR show up in the homework. That's why I want to bring it up. This is what we know of as the molar mass, but it's the relative molecular mass. And so look again at glycine, valine, and phenylalanine. Which one would move the farthest towards the positive plate? Which one?
No, glycine.
Glycine. So the way that you would get awarded the marks is basically by putting gly the farthest towards the plate. Which one would be the shortest movement, the smallest movement out of the three? Glycine, valine, or phenylalanine? These three. Phenylalanine, because it's got the benzene ring, it's a lot bigger. It's got more carbons, is the way to think of it. And so that means that phenylalanine would be, like it would not move as far. And then which one would be intermediate in the middle of the two? The valine. So like that. And so then how do we explain ourselves? Issa, go ahead.
If you have the same charge, they have different molar masses. The ones with the higher molar mass will move the least.
All three amino acids have the same overall charge. Of -1. They all had a -1 charge. This means that they all move towards the positive plate. So it's important to say that. So they all move towards the positive plate. amino acid that moves the farthest is the one with the what? So why did glycine move the farthest? Francesca. It has the lowest molar mass. So the amino acid, so you have to get in here somewhere. The amino acid with the lowest MR travels farthest. Highest MR travels least. That's it. All right, so that comes from the textbook. And then it's funny, we literally only have one question. And that, like I said, was to give you time to work on your homework today. I asked you to bring your workbook because the only way to get better at this is to practice. And this is one of those times in A-level where we actually have the time for you to do so in class. And so I hope you brought your workbooks today to practice for the last part of class. But I do remember this last question taking a while to get through in prior years. So we're going to get to it. So make sure you're paying careful attention. I'm going to do a thorough explanation. That's why it seems so short of a lesson, because look at all the drawing I did on this last slide to explain this last question. All right, so this is how it looks from the textbook, but how does this look on paper 4? So we always want to know. So we've got serotonin here.
Happy.
Yes, that's the happy biochemical. Or peaceful. Serotonin is peaceful. Sure. Let me know when you're good. Serotonin is like peace. Good?
We all need more serotonin.
I think SSRIs, the type of drug class, like medicine class, is like for serotonin itself. For people who have low serotonin, it actually can cause some mental health issues. And so you take SSRIs for that. Like it's a specific type of medical class of drug to like replace serotonin. I think that's if you get like depression, but you can check it out. Serotonin can be synthesized from the amino acid tryptophan. Tryptophan? Do you know where that's in? Have you heard?
Don't even trip, dog.
No? Tryptophan, I don't know if it was just a thing when I was growing up, but we were always told tryptophan is in turkey. It's one of the amino acids that's very prevalent in turkey. And so it's one of the reasons, like, after Thanksgiving, you would get very tired. And because you ate so much turkey in Thanksgiving dinner because of all the tryptophan. Makes you happy because it can be synthesized into serotonin. So you're peaceful and tired after Thanksgiving dinner, usually. So serotonin can be synthesized from tryptophan into steps. So you can turn tryptophan into serotonin. And these are the 2 steps. Let's see what happens here. You get an OH on there. How does that happen? Wait for unit 6. That's where we discuss the organic reactions. And then here they show us that carboxylic acid just like disappeared. How does that happen? But not a discussion for today. They're just telling me the stuff for now. They said, in a buffer solution of a pH of 5.9, a sample of tryptophan does not move during electrophoresis. Why wouldn't it move?
Because
It has to be neutral. Because if you put something into electrophoresis that's neutral, it's not going to be attracted to the positive end or the negative end. So it's going to stay right where you place it. So if it says it does not move, this means that it's neutral, which means that it is the ether ion that we are looking at. And so in a buffer solution of pH 5.9, does not move during electrophoresis. That means we are at the isoelectric point at a pH of 5.9. And then it says, draw the structures of the ions formed by tryptophan at 2 different pHs, 5.9 and 1.0. So I'll do 5.9 first because that's the weaker ion. So this, how would we write this at 5.9? This is tryptophan. What would we be wanting to do? How do we write this at a pH of 5.9? Which is the isoelectric point. Take this H, and move it. Okay, that's it, right? So then you have to copy that into your question. And that's part of the issue is like having to look back and forth to make sure you do it correctly. And so at a pH, I'm going to do 5.9 first. I get this, my bending ring. Then I do 5, like a house. I remember 5-membered ring. I draw it like a little house for the top. House. And then this right here is the CO2 minus. This is the NH3 plus. And then down here, I should have just NH, like that. That's 5.9.
What's the worst you can think of spot?
Question?
I'm worried. If it's,
Is there a question about this?
Yeah.
Or the pH 1? So that's a pH of 5.9. We've got the Zwither ion. Overall charge is neutral because the plus and minus charge cancels out in the whole entire molecule. What about pH of 1? What do we do with the same molecule at a pH of 1?
I think you add an H to the NH.
It's protonate everything that can be.
You have to protonate anything you can, which is 2 places.
Yeah.
It's actually here and here. Because that can still accept, still has an unshared pair here. It can still accept a hydrogen. So rewrite it.
I can do this technically.
By the way, because of questions like this one, is the reason why your paper 4 will be like 20 pages long? Because like some of the questions are just so long and take up so much space for drawing, even though how many marks is that word? 2 whole marks out of the 100-mark paper.
I know
I think no, I definitely missed the carbon. Let me do that again. Imagine if you had to write this sometime. NH3. Did we get that? I'll pause. Because the big question's the one that comes next.
There.
And some of you may be able to do it in your head. Some of you. But for me, I need to draw it out. So I'm going to show you how to understand the next question when we get there. Yes, Andrea. Here, low pH. Low pH means you have to acidify everything. Wait, say that louder. At the Zwither ion, you have to have it like this. That's at the isoelectric point. That's where you don't touch the R group, is at the Zwither ion. But at a low pH, you must give everything that can gain an H plus, give it an H plus. So all should be in the acidic form. Any acid or base has to gain an H plus. Yes.
Like
I know. I feel like I'm in front of him.
put it at this.
What do you mean?
Like-
Where?
Not there.
Here?
There.
Here? That's a carbon.
Like you put that.
Oh! Thank you. That's actually, this should be, how do I fix that? How do I fix that? That's, how do I fix that? I go like that. Thank you, Caesar. Because that's a carbon to a carbon. Yeah, because it has to be from the same place, you're right. I just transplanted it wrong. Thank you, Caesar. Any other questions about this? No? Yeah, because it has to be from the same carbon. I accidentally put it on the wrong carbon. I would have left that one. Sad. Okay, so dipeptide. Last question. This is the one I remember taking forever. The dipeptide PHETYR has the following structure. A mixture of this dipeptide, ether, and its two amino acids, enter, were subjected to electrophoresis in a buffer at a pH of 12. At the end of the experiment, the following results were seen. Spots R and S were very close to each other. The three spots are due to these species, Peter and Peter. Which species is responsible for spot P? Explain your answer. So what do you think we should do first to try to figure this out?
Then
Does it break apart?
It does
Yeah.
say that a mixture of this dipeptide and each of its two constituent amino acids separated are subjected to electrophoresis. So there are three things in this mixture. There's ether, B, enter. So what should we start? How should we start? Anybody have an idea? Go ahead.
Can we separate them by because
So we can separate them. My suggestion is to write out each of the peptides, the dipeptide and the individual amino acids at a pH of 12. So when I started it by writing the dipeptide. Dipeptide, which is PHETYR. Peter. So at a pH of 12, what would that look like? The same thing. pH 12 means what? Acid or base? Definitely basic. That's actually considered 12 to 14 is strong base. So they're telling you that for a reason. They're like, hey, this is strong base. So how does that mean that I would write this? So how would I rewrite this in strong base condition? What would I have to do? Add self.
Remove the H from the CO2H.
Remove the H from the CO2H. Is there any other H's that also get removed? These are from the phenol. So there are two H's that get removed. Some of you in your head may already be like, okay, got that. That means it's going to have a -2 charge. And if you got that and you can hold on to that, then you don't have to draw the whole thing. But I'm going to draw the whole thing just for, making sure of understanding. And so I'm going to draw the whole thing. That's why I did 2 per slide, was to give space. You want to draw the whole thing. And it's copy paste H2N. This NH. Oh, there are no marks for drawing here, by the way. This is just to understand what's going on. CO2 minus. And then here, O minus. So then what I wrote on the side is that the overall charge is what here on this molecule, the dipeptide. What's the overall charge? Nope. -2. The overall charge is -2. Because this affects how it's going to move, the charge and the size, remember. And so what else do we need to know? That's about dipeptide. What else is here? They said it was the dipeptide and its 2 constituent amino acids. So somebody suggested we'll split it apart. Let's split it apart. Where would this split apart?
The carbon between the O double bond and the N.
So right there, right? The peptide bond would split apart, which is the amide bond. So then I'm going to write, and it's in the order they say it here. So if they say B, like that, it's left to right. So if it's B tur, this is B and that's tur. They write it in order. So I'm going to write phe next. Phe is my specific amino acid, phenylalanine. And so that would be this. I'm just rewriting this. pH of 12. And then what would come after this double bond oxygen? where it gets split. It would typically be OH, right? But we're at a pH of 12.
So you have to be just another code.
So what would it be? pH of 12 means that you take away the H plus, right? So this should be O minus. Are we okay with that?
Mhm.
Okay. That has an overall charge of -1. And the last one is tyrosine. Tyrosine. T-Y-R. So now we have to draw the right-hand side to this. So this is going to be N-H. What do we got to put there? H, right? And then what happens to that CO2H? What does that become in a pH of 12? CO2 minus, right? And then down here. And what happens to the phenol at a pH of 12? O minus. That's an acidic group. What's the overall charge here? Okay. We have enough information to answer the question. Yes.
Stupid question. How do I know which side is P and which side is left? Is the
Left, right. Feature, left, right.
okay?
Like the way that it's, if they had said turfy, it would have been turfy. Does that make sense? They write it left to right, and then they also draw out the molecule left to right. So the way that it's written is the way that it's drawn out left to right. So you understand which amino acid comes first, which one comes next, and how they're connected in the middle. Okay. This is the information we need to solve the question. Which species is responsible for spot P? So the mixture was applied right there. This is the negative end. This is the positive end. All three of your molecules moved towards the positive end. But one moved much farther than the others. Which one moved much farther, Francesca?
It's here.
Here. Why would it be here? It's here, correct.
It's more negative.
So TYR is the correct one. It is because it has an overall -2 charge with the smallest MR. So therefore it would move the furthest. So overall -2 charge with small MR. So it's going to move the farthest because it's small and it has a large negative charge. But you may say to yourself, but there was something else that had a large negative charge. Same negative charge of -2. Why would that not be the answer? Atzel.
They have a larger MR.
Because it's a larger MR, so it's going to be a move less. So that's actually going to help you with the second part.
Great.
And by the way, for the 2 marks here, I was looking at the mark scheme last night, after I solved the question. And literally, somebody would be very happy with this because all you have to say is -2 charge, small MR. Like that was it for the 2 marks. So technically, you don't have to write all of this out. Writing this out just helps to aid in understanding why this is. But some of you may be able to do this, like I said, in your head and add the negative charges, like take away the hydrogens or add them. But I'm writing it out because I think it's helpful to see what's going on. All right, so that's that one. Suggest why the other 2 species give spots R and S that are so close together. That's for 1 mark. Why are R and S? Which means why are these 2 almost at the same spot? What's the reasoning? Francesca?
Because R, well not R, I don't know which one is which, but
Well, I mean, you could just call them feeder and feed, right?
feeder is very large and has a larger MR, but it has a larger
Charge.
yeah.
So this says it's going to move farther, but this says it's going to move less,
Yeah.
right?
And then the other one has a less charge, but it's also, it weighs less.
So the effects cancel out each other. Very good. And so the way that they said it, you could say a couple of different things. One thing you could say, this is probably the least amount of words, is the mass charge ratio is similar. So if you said mass charge ratio, like the mass to the charge, is similar, that gives you the marks. So you could say that. You could also clarify and say that B-ter has a 2 minus charge with a larger MR, whereas, which I believe is around the area that Francesca said, whereas B has a -1 charge with a smaller MR. So that would be a more full explanation, but literally you could just say mass charge ratio similar. Bigger mass, bigger charge, smaller mass, smaller charge. It cancels out, like double the mass, double the charge, gives you the same effect, is the idea. And so that actually, and look at 30 minutes left in class. That's what I thought. So even with taking a long time to explain each question, this lesson was just one standard that you need to be able to cover. This could be 3 marks on your test. You've got time to work on your homework. So I asked you to bring your workbook so that you have the time because your homework is technically 10 pages from Unit 5, Lesson 2, and then another several pages for Unit 5, Lesson 3. So start working on your homework for the last 30 minutes of class. Got time. Yes, we can get your thought. Stefan, Sophia. You didn't finish.
Yeah. If ever there was a worser weekend.
Bro, literally.
Yeah.
Yeah, the 26th.
Hot damn.
So it's the 26th. Yeah, the 26th, the 27th, it's possible. And then maybe we can get 28 to be Vincent. And then the second
6 chaperones they need for the March 13th.
I don't think it's 20th to do the thing, is it?
Underclass
20th is to do the thing. I thought it was like basically it starts at like the time can start doing it.
No, it's
Why is everything the day that everything else is due? Jesus.
This week could only be in the 9th grade. It's Friday, March 13th.
That's probably gonna be the day we do the March 21st. So that means
That's the day STEM challenges do.
that's gonna be the math. That's the day that we
That's the most important
because it's always on time.
Oh my god.
Oh yeah, Pi Day's a Saturday this year. Probably do the Mike Day math challenge day.
Yeah.
Awesome. That's
March
great.
13th, so you won't have.
Scheduling is phenomenal.
This isn't crazy.
Clearly. Scheduling 5,000.
I like it.
I like it.
It depends. Like you could play some little, you could play some also work.
This is how you know you're getting towards the end of the school year when everything just starts piling up.
In one they
The
have
density of
but they have it closer.
increase.
When it's
Like it's still on the side of the thing.
I believe it's
It's
the
advanced.
first.
So the difference.
It should be the global
And then
paper.
it's here. There's the ones that you have to
The hell week. It's something.
No, but we have.
Our
We have.
next is
We
B
got 2 hell weeks. What's
because they're close to each other. You can't
Yeah.
differentiate.
Give one over.
That's
I
what
the
this
other one
is
has.
basically saying.
Give.
Because
one
one has.
I have, like,
mass,
I have-
so unit charge. So the 2 factors cancel out each other. So
I have 1 hell and then 3/4 of a hell.
You also have media
Step
Yeah, media studies.
with the -2 charges.
And then some of the, make this, you add it here, and then for this.
Yeah.
Yes, you're today.
And this will have the.
Oh,
Well, this will have the. Oh.
It isn't that bad.
I know. That makes it against 2.
It isn't that
I'll
bad.
tell you, Frank, I'm going to study for this, and then everything else will just happen.
Mechanics
Really?
like
I'm just going to throw it to the wayside.
Actually, yeah.
Hope for the best.
I'm probably gonna maybe focus. Yeah.
That would be-
Wait. You know what? Like I've got an idea for global, right?
That's-
I've got an idea for global, right? So my global idea is that I do something related to English, so that I can study for English while
While
doing
doing
global.
global.
No, so that's what I'm going to do in the English topic. I know, but I'm probably going to do the English topic. It's a
I don't think that's like an
no, but it's a good global question though,
I think you should.
and it also has like a lot of perspectives.
Safe thing to pick, you know what I mean? Your third.
Oh, that's an excellent question.
I thought that is. I don't think it's really.
History specific.
Listen, I don't think it's that.
Yeah. Then we have chemistry.
I think the May 19th was the history EOC or something.
Oh yeah, the history EOC. Yeah, and then we're gonna have to like cram the history EOC.
It is not. I'm not.
Daniel, what year was 1776?
Keep in mind, maybe it was 1776.
Oh yeah, okay, good. You got it right.
Well, basically, it's so that we have to pick one to pick.
Listen. All I'm saying is that like if you pick English as your little paper, just get like a month of studying or two, and then boom.
Like I got an A and then yes, I can do nothing because
Wright's name.
yeah, that's like
Wright's name. Great success.
So you have it.
Much academic. Oh, that's hilarious.
Less of the cats. How dare!
You somehow write your name wrong.
Third homework. It's due Monday. Because I was sick and then I tested. So it's due
Yeah.
next class.
Cheeses.
Dude, cheeses, several cheeses, including Colt Jack.
Look,
Cheese.
look.
No, I have my turn. Yeah, with coffee. And that's very perfect.
It's not real. Didn't happen.
Yeah, I just remember
Now you can prove it.
the whole
Yeah, 20 pages of homework.
It's fire. Everything's happening all of the time.
Oh yeah.
Everything's happening all of the time.
Be happy because all right.
Subscripts. Math. Subscripts. My brain will be like, subscripts. That's probably an exponent. And then I try to use exponent rules. That's not how that works. And Morales, I did it. Morales flinched. He was so disturbed. Look.
Well, are you sure you want me to answer them?
Sorry, it's like don't worry.
Danny, what about you?
Right here.
Right there.
All of them.
Really can.
They get weird.
Danny. I haven't done nothing.
Let's do next class.
Damn. Okay.
Why not?
How we doing?
He's can I have your
Oh, you can be next.
Expands F plus 2 squared. Realizing this is
The homework?
puts F plus 2 squared back together again.
It was something on.
Unnecessary.
Oh, you look at it looks like a happy face.
Because it's basically it's not my job.
Allowed me to get the negative.
Here.
Original thing, making it negative. That's negative 1K.
Oh.
Yes. So I'm doing this. I got the connection is the ALA 9.
Yep.
I'm not sure what it is. You always plug in an But they always plug an NH to connect it.
Yeah, because you're
Yeah, they go like
So yes.
more towards
So this
the
would be
big
NH.
have charge.
It's NH.
This is literally nothing.
Just done.
This is I pointed to.
Each one gets, you just take out the
And
water.
then the carbon, the hydrogen.
There we go.
Whatever.
It's mixed.
So it's you do inductions, you do a trig idea, you keep doing your inductions. Where's
I have some.
Or no, it could be like the entire thing right here.
What do you mean the entire thing?
Like right here, it'd be like the where the board of this thing.
The board? Maybe.
Yeah, and that's why I think it's correct.
Why?
Because, like,
Also, I'm convinced that's notational.
It's either, it could also be this.
It's the 19th,
Yeah, that.
which most of my students.
This thing or
How
this?
many do they need?
The whatever that is.
That's
That one.
brutal.
That's insane.
Well, it can be run off.
Does that mean that day we're just not gonna have classes because everyone's gonna be
No, I can't miss that day. It's STEM challenges do that.
Right,
I
yeah.
can't miss that day. It can't be me.
They're going. They're not
I'm already
going to push hard,
committed.
you know?
They're gonna what?
They're not going to.
They're going to Islands of Adventure.
Yeah.
I'm already going to Islands of Adventure. Or I'm going to Epic Universe. So.
Oh wait.
You're gonna go to
I
Mario?
think it's
You're
the
gonna
reason-
shoot Mario?
I went like
This is the mixture
3 days. I don't
of
know if you remember.
LA,
I
Sir,
went
and
for
Glee.
3 days.
But there's
But I went to the
four.
one in Los Angeles.
Shouldn't be.
So because they haven't went to the Angeles, they're going to. I have not been to the one here yet. I hopped on the field trip. I was like, let me go to the Epic
It's, but
Universe.
why does there only not, it doesn't show all?
Somebody's out right now. You're in line though. You can be after Samuel.
Show the cathode and this is, I mean, this is the anode and this is the cathode.
If I can go on vacation, separate
Because you're going to the positive.
They haven't even learned about it.
You should just leave it there. Yes.
Leave it just like that. It's like totally got it. No, he's in six.
You can't use it.
Why haven't you watched the Jets?
I don't know where you've been, Danielle. I don't know where you've been.
What?
You're saying it.
And I don't trust.
They even
Oh, yeah.
double you or something.
You might.
I
You
don't.
might. Who knows?
He says I believe in them.
I didn't say that you do. I said you might.
It's basically saying like,
I said you might. I'm just being annoying.
You think just ask and then.
They'll stop not touching me. I'm joking. Mostly just to bother you.
And then because like when it, so if I match my time tracking, I can do histories in English.
Okay, so you're gonna. I keep telling myself we aren't back going to find someone for the
Bro, I hope we do it. I really don't do it.
Roll for one.
wait, this is
Which is
What is it about?
no, because I'm in this team now. Luke dropped it.
yeah, that's what I'm saying.
So I'm stuck with.
see what it feels like.
But you still
How do you understand? No, we were joking that I was gonna get screwed over for being on time with the form,
He was screwed over because he was on time.
which is some bull.
I did see that.
Do you not understand? Oh, none of you filled out the form. We wouldn't be in this situation. But you people would just fill out the form.
I think I had the same theory, but I didn't do the homework yet for part 3. I did part 2, and it took me forever to do. That's why I was like, you get extra time for that.
So you haven't done